Thank you so much for joining us today. My name is Inbal Shani. I'm the General Manager of AWS Elastic Containers. I've been with Amazon for 5 years now. And today I'm very excited because we have a very special guest joining us today, and I'm thrilled to have him with us. Gary Chen, he's the IDC Research Director for Software-Defined Compute. His research is focusing on server visualization, containers infrastructure and management, as well as cloud system software. And Gary has some great perspectives on trends he's seeing in the market with infrastructure and containers management to share with us today. So I'll be back in a few minutes, but for now, let me turn it over to you, Gary.
Great, thanks, Inbal. Yeah, so I'm here to talk about the state of enterprise containerization and some of the trends that we're seeing and the growth of containers. So to kind of set it up, we've been in kind of this era of virtualization, and that's kind of basically when I started in my analyst career. It was at the beginning of that era. And why are we kind of moving from VMs to containers? So VMs were initially designed to partition and consolidate servers. But then it started being used for a lot more things. People started basically putting only a single app in a VM, and that basically made a VM equal an application. And so with that, if you're doing VM management and orchestration, you were essentially doing app management and orchestration. And so when a VM image, was an app image, and so that gave rise to a lot of things. Most importantly, I think cloud computing, virtualization enabled the multi-tenancy that happen, but it also, gave it the capabilities to orchestrate, provision the servers, and that was huge. Um, and then containers came around. Containers in some form have been around for a while, but it was really this kind of esoteric sandbox kind of thing. And what happened was when Docker kicked this whole thing off, they really found a way to make it developer friendly, and the market exploded into this huge, lots of different platforms, a huge ecosystem. And it was really a perfect fit as apps trended towards microservices and cloud native, having a more lightweight and really efficient, scalable, and most importantly, I think an application centric way to package and manage apps. VMs was really an infrastructure construct, and containers developed as something that really understood what was inside the container and what the application did. And so what we're seeing is, there's a huge ecosystem impact now. It is very similar to what virtualization kicked off. When that started, right, there was implications all across the data center. How did all these other systems have to, change and work with virtualization? That's very similar with containers, right? Containers work at a different speed. They have a different management approach. When you start breaking down an app into microservices, there are a number of things you manage, data it produces, kind of increases exponentially. So all of these things, storage and networking, security management, they're all kind of changing, as containers rise. And so this slide shows the historical and the forecast model for different computing models. So this shows where the app is primarily deployed. So for containers, yeah, the container can be running in a VM or can be running in bare metal, and that isn't really differentiated here. But the important part is the app is deployed primarily in the container. And this also shows, where apps are deployed directly on bare metal or into a VM. And what we're seeing is basically, bare metal has been shrinking for quite a while, and that continues. It even kind of accelerated by containers because, things that couldn't be put into a VM, a lot of those things are put in a container. So, that really kind of accelerates, kind of the further erosion of that. VMs are still growing. But containers really are growing the most at 52% versus 7% for containers. And one thing I think to keep in mind is, even as we see this massive growth in containers, VMs aren't going to really disappear overnight, right? VMs are still a very stable, mature technology. There's lots of data centers that run in them. There are a lot of cloud services that built to them. That are very good. They're going to continue on for the foreseeable future. And most containers will continue to run in VMs for a lot of reasons around security and provisioning. So we're going to be in this mixed world of VMs and containers for a long time. That's not to say that VMs aren't changing, in the face of containers. For example, there's a lot of projects that assume that the only thing that a VM is going to run is containers, and there's a lot of optimizations you can do to make the hypervisor more faster and more efficient. So we see that driving a lot of serverless and functions as a service and other things. Um, so both of those technologies are definitely going to coexist. Now we're going to look at the same chart, and let's say we normalize everything to 100%. You can see kind of the percent compute for containers. So right now we're like just under 20%, and we're heading to about a third of all compute being containers by 2025. And so what we're seeing is that the growth of containers is driven mainly by modern applications, right? So these can be new greenfield applications or existing applications that are refactored. So these types of apps are moving the fastest towards containers. But that transition is going to be a long one. Enterprises don't always have to have the opportunity to build something greenfield. The existing apps, right? They can have a lot of technical debt. It can make refactoring a fairly long and complex project. But that is the path that's happening, and what we're seeing is that as I mentioned, VMs and containers are going to continue to coexist. And what we're seeing, at least in the container stack, the VMs are still going to be used, kind of partition that server, for a lot of isolation and security. But a lot of the app management functions, it all moves up into the container layer. And so if we look at kind of where containers are being deployed, right, this shows the distribution of container instances across on-prem and public cloud. So both are growing pretty fast. That's expected, this new exciting technology. But the public cloud has been growing the fastest. So, we've seen that, public cloud has always had, kind of the affinity for containers, because this whole term, a cloud native app, however you want to define that, a lot of that usually means that the app is using a microservices architecture and that it runs on public cloud for a bunch of reasons, right? It could be just using the infrastructure services underneath, but it also could mean that the application is using a lot of kind of application and data level cloud services, which let developers offload some of these functions and build apps faster. And so that's why we're seeing kind of the growth shifting to public cloud. And if we look at that same data, again, normalized to 100%, where you can see, the percentage of public cloud versus on-prem, this shows, some of the interesting changes. So what's interesting here in that red arrow, there's a big jump in 2020 that kind of matches to the pandemic. So, public cloud was, already growing before the pandemic, but what we saw was that really accelerated as businesses just, really had to react suddenly to, a new way of working, new ways of transacting business. And it's not that that was something new, it wasn't like a path that people weren't already on, in terms of increasing agility, creating these new digital experiences, but it really kind of gave people kind of a kick in the pants on the timeline of when these things were needed. Um, and so people started deploying more and more in public cloud in reaction to that. That was the fastest way for them to react to a lot of those events. And what we've seen is that those kind of behaviors really become permanent, right? If you get to used to building cloud apps, your organization continues to do that. And after a pandemic, those things don't really kind of move back on prem. So that's why you see by next year, the 2/3 of containers are in the cloud, and it sort of maintains that ratio over time. And this slide is from a survey of container users, and this was, infrastructure and ops people, not really from the developer point of view, about what the top drivers are for people to deploy containers. And so the two top ones are security and RAS. RAS is reliability, availability, and scalability. And so security's really been kind of the top one for a number of years that we've done this study. Um, and it's kind of interesting because when we look at security, there's a lot of different facets that when you talk about containers, but there's a lot of features of containers and container platforms that actually helps people with security. And so a lot of people are seeing some of the benefits. So, one, it's another layer of workload isolation, on top of a VM. So if someone was to try and compromise something, they had to break out of a container and then break out of a VM. So, makes it more difficult. The other thing is really kind of better software asset management that we've seen. So, with container images, there's a lot of metadata, sort of a bill of materials inside, and it's stored in a centralized container registry. so that people have an idea of like, what to have deployed. So if there is a, component that they know is vulnerable, like Log4j, maybe they can search in there and find out, what of my images use that, and then you can update them. And the updating is also a big factor as well. So, people usually with container systems, right, people set up this automated kind of CI/CD pipeline, and that's let people do kind of basically faster patching of systems when they need to, and they can make it also less risky. They can do certain patterns like blue green and things like that, so they can have more confidence in case something goes wrong, that they can roll back. And the other thing that we've seen is, well, a different architecture, right? When you move from a monolithic architecture to a microservices architecture, that really lets security teams have different postures for different parts of the apps, right? When it was a monolith, you had to defend everything with kind of a single policy, a single posture. Then when you break it up, certain parts of the apps are more sensitive than others, and you can set it up with different levels of security. And then the other part is really immutable infrastructure. So that's sort of a cloud and a container philosophy where you kind of have this infrastructure that is immutable and changeable, and you roll out new versions instead of trying to always trying to change live configurations, and that leads to like more consistent configurations, which is a big part of security. So those are some of the security aspects of containers that are beneficial to security. The other part that we're seeing, the second one, RAS, that's really kind of been, if an infrastructure person, that's kind of like your primary mission, right? To keep the thing available and performant. And so containers can help with that, right? So there's inherent features of containers that improve things like scalability. It's much more, it's easier, it's more reactive to do that. As well as, I think cloud can play a big role in that as well, where you kind of see the movement of containers to cloud. When you're using either when you're just using cloud infrastructure to deploy the container software, or you're using like a fully managed container services, all of those things can help increase RAS, rather than you trying to take on the task of doing those things. Um, and then if you kind of further dissect this chart, so beyond the top two, right, there's kind of like a lot of things clustered in the middle, which, shows that, I think people are doing containers for, different specific reasons, but they all kind of group into several key themes. So, some of the themes that we've seen here is one, supporting new modern apps, right? And you see these in various categories, right? Some of them are it's AI and big data, some of it's microservices, some of them are refactored apps, some is edge of IoT, but there's a a new class of apps that are coming into being, and container is kind of the optimal platform for that. And the other part is really just around velocity, right? Increasing the velocity of software deployment. So whether that's faster development, more developer productivity, but that's also at the infrastructure level, right? Infrastructure efficiency and management efficiency. How to get software, reliable software, out the door faster and running in a more performant and scalable fashion. So yeah, I think those are a lot of the buckets that those individual kind of subtopics kind of fall into. And so if we kind of dissect further into kind of how customers are deploying containers in the public cloud, what we've seen is kind of, a huge trends towards fully managed container services, where today, almost 70% are in a fully managed model. And 2 years ago, that number was 58%. So it's been growing steadily. Um, and so one part of that is because, building and operating container infrastructure at scale is incredibly difficult, right? These container platforms are very broad, they're very complex, and that complexity has actually been growing over time, right? As they're adding more and more features. Um, and so it's a very difficult thing to do. And the second is that enterprises have been kind of migrating over to this cloud operating model, and a big part of I think that philosophy is right is to stop doing undifferentiated things, like running container clusters, and bring kind of your focus and your expertise to things that differentiate your business, and that's really more around creating applications, right? Creating digital IP, creating customer experiences. And so I think this is why a lot of the infrastructure responsibility is being moved to cloud providers, and actually doesn't really even stop at infrastructure. Right? So many common parts of applications, like a database or analytic functions, those are being offloaded too, so that devs can focus on other parts of the app and build things faster. So we've seen this kind of general trend towards offloading a lot of these very common elements to managed services. And this slide is really interesting. So we saw the kind of the jump around the pandemic. In terms of the the movement to cloud. And so what we've seen is that coming out of that, really containers are becoming kind of the foundation to drive the innovation and modernization for the business. So one, it enables a lot of experimentation, and more importantly, fast cheap experimentation. So that lets you do more iterations, figure out what works, and capitalize on the successful things. And that in turn kind of enables this technology-driven business and digital customer experiences that the whole world has been moving to, with everything being online and mobile and other technologies. So what we've seen, so when we asked people kind of in the middle of the pandemic, how are people reacting to this, right? So one, we know that people are the pandemic showed a lot of weaknesses, in how fast people could do things, the agility, the ability to adapt to some changes. And so they're gonna, when they go, they've gone back and deconstructed, hey, this is what happened, this is how we reacted, this is where we were deficient, and they're gonna invest in capabilities to shore up the weaknesses that were exposed. And containers are going to be a big part of that. And then the other part is really looking at the digital experiences, and their digital transformation. And so that capability was key in being able to react to that. And so yeah, they're going to reinvest in all of those digital assets, to strengthen basically their business, and further adaptation to whatever is going to happen, right? The world is becoming kind of in an unpredictable place. So whatever the next event, they want to be ready for that. And so when we saw kind of the benefits and the drivers, why people were doing Kubernetes. And then we asked people, what were the top challenges? And interestingly, security, was a top driver and benefit, but it's also the top challenge, right? So containers are a new system, right? Users kind of are worrying about learning the security ins and outs, right? Do I know where I'm vulnerable? Am I making just really basic configuration errors, that would expose me? And so, while there is benefits, security benefits to containers, there's a lot of security concerns as well. And I think this is one of the reasons as well that we're also seeing a lot, the uptake of container cloud services, and where you can offload some of that security responsibility to the cloud provider, and their expertise in securing those systems. And then the second thing that we've seen, the second challenge is really around data management and protection, right? So as workload complexity grows, and more critical applications are being put into containers, that generally means more stateful workloads. More containers are creating, accessing, and modifying data. And so, as the data grows over time, how do you manage and protect that data? The third thing is really around existing applications, right? So enterprises, realistically, they just can't drop all their legacy apps overnight and move to just brand spanking new ones, right? So, it's a long period of transition that will mean modernizing and refactoring existing apps. There's often a lot of technical debt and support issues. Um, and so that's a major challenge for customers. And the rest of the challenges, I think most of them, if you look at them, some of them are very specific to something like storage or networking. But most of these challenges kind of stem just from the difficulty of kind of maintaining, creating, and operating this really complex, very broad and robust container platforms. And so what we talked about before, containers kind of impact the entire ecosystem, right? So users really have to relearn and re-implement all the tasks that they've done before. right? So people know that they have to do data protection and they have to, do storage, but it all works differently in containers, right? So they have to learn how to work with the new system, and then often with new approaches that are happening with containers, right? With DevOps, some of the cloud operating models. And what's making that worse is container skills are a scarce resource right now. People with that kind of expertise is very hard to find. So that will probably take some time to resolve, but for right now, people are struggling with that. And so if we look at, the workloads that are actually being containerized, if you look at, what's built kind of greenfield and existing applications that are moving to containers, it's almost split fairly evenly. It's slightly tilted towards existing applications at 54%. But what we've seen that, customers are still getting benefits from containerizing legacy apps, even if you really make no code changes, right? You can still get, better utilization, higher density, right? It's a better way to, faster way to distribute the software. You can have a more modern workflow. But a lot of those applications, right? So 38% of those existing applications, right, in that dark blue, those are going to be refactored. Um, and often that's in multiple phases, kind of over time. How much of that refactored is still kind of variable, right? You would love to say everything gets to microservices, but there's some there's probably some point kind of in between. We kind of jokingly call it like macro services, right? So it's kind of in a halfway state. But people are definitely trying to modernize these applications, and some of these things are, the rest of them are going to be kind of basically lifted and shifted over with little to no change. And for some applications, maybe that is the best way to kind of live out its useful life. So a variety of approaches to kind of what people do with these existing applications. But that is the reality for enterprises, is that they've always deal with many generations of technology, and legacy assets over time. And so, the modernization is definitely going to be a long-term thing. And so kind of to wrap it up, so, looking at, we looked a lot at the current state, where the, drivers and challenges are, what's being containerized and where. And so kind of, a brief look into, so what's sort of the future for containers? And these are a couple of things that were kind of on my list. So one, these new methodologies and processes, right? So DevOps, I think, is pretty common these days. But it's all about kind of people optimizing further, right? New methods, something that's faster, something that's more reliable, right? So people are doing things like GitOps, and you can put whatever you in front of this word ops. And I think what that really means is that for a lot of these things, it's like and we've seen DevSecOps and FinOps. It's basically bringing in other groups and functions without slowing down the process. Right? Like, how do we get security involved? How do we get finance involved for cost optimization, and how do we do it without them kind of slowing it down? Do we can we bring them early in the process and make them part of that? Um, so I think on the methodology side, that's what we're seeing. um, I think edge and IoT is really starting to grow. So outside of core data centers and different types of edges, right? There's thick edges and thin edges, all the way down to very small devices. But containers, I think, are a really good fit there. They're lightweight, really efficient for those kind of smaller, thinner devices. And that containers, I think, were built kind of with distributed systems in mind. So it's really good in dealing with things that are kind of spread out all over the place. Um, then I think another issue is, like, we're see technologies about how to deal with scale, right? As people, it's containers that make up more and more of people's compute, right? How do you manage hundreds or even thousands of clusters that across your own data center in the cloud and the edge? How do you make sense of the huge amount of data that's going to generate, right? So AI could be an interesting um, solution to that, right? AI is already kind of pulling interesting things out of mass amounts of data, but can AI, can it actually make decisions in the data center, operational decisions, and execute changes and actions, right? So this whole concept of AI ops, that I think could be a very interesting way to deal with the challenges of that. Um, And I think, one of the really big things that I've been seeing is, this is kind of across a lot of very, very different technologies and things, but, overall kind of just better abstractions, both for the infrastructure person and for developers, right? So a lot of it is like, do you really need customization and control of some low level thing, right? Can you trade that for something standard that has more automation and abstraction behind it? So I think that's an interesting question. And so, I think for infrastructure people will see things that, how can I simplify, a very complex distributed system, and a lot of them, how can I manage that? Multi-cluster management, um, as well as, can I do something with serverless, underneath, right? So serverless, I think, has, a couple different applications, right? Underneath containers, right? Can I have something to abstract away the infrastructure as a service and, my worker nodes, right? And then there's also a layer that can go above that container infrastructure, kind of like an easier way for devs to push a container to production, get it up and running. And kind of, above that, we can see more platform as a service. But it's sort of, I think, a different generation, right? It's lightly opinionated. It's more customizable. And running on a container infrastructure, and even higher than that, right? We see functions as a service. A lot of that can be built on the serverless and the containers underneath, and most of these function systems do use containers on the back end, but all of that is really fully abstracted, right? You're only kind of dealing with just uploading the code and functions. And then the last thing we've seen is kind of, local cloud services, and we've seen the trend of containers, moving to public cloud and moving to managed services, container services in public cloud. A lot of that is actually coming back on-prem, right? So what we call local cloud. So having fully managed container systems on-prem, and we've had kind of remotely managed services, but this is sort of different in that these things are really kind of extensions of the public cloud. So it's public cloud, but in your data center for a lot of applications that for some reason need to stay on-prem, but you still want to kind of leverage that cloud model. So we're seeing growth in that area as well. And with that, I am going to wrap up, and thank you for your time. I'm going to hand it over to Inbal, but I will be around later for Q&A.
Thank you so much, Gary. This is super insightful research, and it's definitely interesting trends. And the things you covered aligns really well with our path forwards in container. And I'm going to dive into some of the things you just mentioned in the presentation today. So we talked about what Gary just mentioned was his perspective and some of the research he's seen on kind of the landscape and where the market of containers is going. For us, it's a huge part of our guiding principles is that we rely heavily on what we call the voice of the customer. And as you know, customer obsession is one of our key leadership principles, and we live it every day. And the feedback that we get from our customers help form our path forward when it comes to our roadmap and design decisions. So what we aim to do, especially when it comes to containers, is we want to take away a lot of the less undifferentiated heavy lifting. We want to take it away from our customers so you can focus on application development and focus on what you do best, and let kind of utilize the vast power of AWS to help solve some of these challenges. And we know our customers, we know you guys, and we know that you want your teams to focus on delivering application as fast as possible. We also know that you want an infrastructure that can be customized for your needs. We also know that scaling matters, and you want to be able to scale your services and application to whatever size you need. And you also want to be able to do it really quickly. In addition to that, Gary called out security. So security and isolation, access control, permission, super important. And we focus on that in every AWS product we put out there. And eventually, these becomes our tenets and our guiding principles when it comes to the containers business. And these are some of the reasons why we build relationship with Docker and why we launch new tools like ECS and ECS Anywhere. And some of the benefits to our customers include that we're moving to more control, repeatable environment and kind of embracing automation. We also see, Gary touched about developers' productivity. So we see the productivity increases dramatically, speed increases dramatically. And while we focus on improving quality, stability, and of course, security, And then if you think about it, by letting AWS handle infrastructure and operations burdens, then the customers can be able to focus on reduce the risks and focus on building business logic instead of infrastructure. So when we're talking about AWS modern application services, ultimately, the choice of compute is never just about the compute service. It's also about kind of what the platform is, where it runs, what are the options that are available for you. And at AWS, we try to get you covered. So this means we have different opportunities, different solutions across the different layers. And what it means is that you get event integration or application mesh, and it's also everything is natively integrated. And then if you want to use other tools, we also have third-party tooling options that are included. Things like Grafana for analytics or Datadog for monitoring. There are other security tools and many, many others that we support. And then the ultimate thing is when you're running containers on AWS, you have many options. And the first thing is you need to choose wherever you want to manage to use a managed servers, or in that point you can choose Fargate, which is our serverless offering that Gary mentioned, that it's a big trend in the market, as well as kind of focusing on using Amazon EC2 if you want to control over things like installation and configuration and management of your compute environment. And then the second choice is the choice of orchestrator. And for that, we have multiple offerings, and I'll mention two. So we have Amazon Elastic Container Services, and we have Amazon Elastic Kubernetes Services, so ECS and EKS respectively. And then one of the most common requests we hear from our customers is, help me choose. I don't know which containers to use. What we recommend for most teams is begin by selecting a container solution that has the most attribute that is aligned with your application requirements, as well as your operational preferences. Both ECS and EKS support a broad array of compute options. You can see some of them here in the slides. Both of them have a strong integration with other AWS services. They also provide global, scalable, and reliable solution. And they're coming with everything that AWS is known for. And what customers tell us that they love most about ECS, for example, is its simplicity that it provides. It delivers an AWS opinionated solution for running containers at scale. It also helps reduce the time to take customers to build, deploy, or migrate their containers application successfully. As well, it is designed for simplicity from the start. What does that mean? That means that using Amazon ECS decreases the number of decisions our customers need to make around compute, network, security, configuration, and all of that without sacrificing scale or features. So for example, if you need a load balancer, then AWS Application Load Balancer, ALB, or Network Load Balancer, NLB, integrate seamlessly with Amazon ECS. So you don't really need to build or maintain generalized abstractions. Now, the second choice you have is Kubernetes. And then why does teams choose Kubernetes? It's mainly for its vibrant ecosystem and the community consistent open source API and kind of the broad flexibility. Our customers rely on Amazon EKS to handle the undifferentiated heavy lifting of building and operating Kubernetes at scale. Amazon EKS provide both flexibility of Kubernetes, but it also offers the security and resiliency of being an AWS managed service. And it's optimized for customers that are building highly available services. Now, Amazon EKS provides a secure, reliable, scalable, and resilient Kubernetes environment for customers such as Intel and Snap, Intuit, GoDaddy, Fidelity. It also helps Amazon.com to deliver an incredible customer experience. So we see customers adopting Kubernetes if they want a resiliency of AWS that could start with Amazon EKS. Now, choosing a container service at AWS doesn't need to be a binary decision. Amazon ECS and Amazon EKS, they work together seamlessly. They have shared operations, same integrated security tooling, common IAM, consistent management tooling for compute and network options. You can take advantage of the simplicity of cohesive AWS services in Amazon ECS, as well as using your own flexibility of Kubernetes with Amazon EKS. So for the purpose of this session, I will focus mainly on the overall containers management services, which for us includes core container services, ECS and EKS, our serverless compute services, Fargate and Lambda, as well as our application optimized services such as Batch, App Runner, and Copilot, as well as I want to mention our Anywhere solution, which are relatively new services available for both ECS and EKS customers, especially targeting customers that needs to maintain their hybrid environment. Now, I talked about how much we value customer obsession as our leadership principle and how the voice of the customers kind of help drives our roadmap with Amazon ECS service. So let's talk a little bit about the history. ECS was launched in 2014, and it was the first managed service for customer, and it took off pretty much as soon as it was launched. With the time, we continue to grow the portfolio with a very specialized abstractions for running batch jobs with AWS Batch. In addition to that, we followed up launching support for serverless compute with AWS Fargate, and the idea was to reduce EC2 infrastructure management overhead. And then in 2019, we launched support for capacity provider, and the idea was to reduce auto-scaling overhead and reduce costs for faster scaling with Fargate and Spot support. The idea is to work through capacity providers working together. And then Containers Insight, we talked about observability or takeaway management. We want to be able to provide you more insights into what's happening in your environment. So CloudWatch added visibility into running tasks, services, and so on. And then we added Copilot. We talked about developer experience. And we also added App Runner recently as kind of an abstraction that customer could use to onboard and run ECS underneath. In addition to that, recently, 2021, we launched ECS Anywhere, a new console, as well as ECS Exec with a focus on troubleshoot and faster launches. And if there's one theme that you should take away from these features is our goal is to take more of the management overhead so you guys can focus more on developing your application. So with ECS, the serverless control plane is highly available. It has a failover in multiple regions. It's globally available. And we have performance of tasks per second. Now, ECS, most importantly, has a managed control plane. And this means that there is nothing to install. So why do customers choose ECS? Main reason is because of ease of use. So they can simply go faster. You want to go to production fast. You want a fully managed control plane, and that allows you more resources for your application. Second thing is the turnkey integration. So turnkey integration with all the common AWS services and features, IAM, load balancer, security groups, ECR, CloudWatch, and these are just to name a few. And then in addition to that, ECS is proven at scale, performance, and security. Now, best of all, the total cost of ownership and no management. Now, ECS is free. So you actually only pay for the underlying resources that are used. There is no control plane management overhead. And then with ECS, everything is fully managed. We're continuing to push hard to deliver new features and improvements in all these areas, including things like more intuitive console experience. ECS also is supported directly in the Docker CLI and the desktop app, as well as improved support for GPU, ARM workloads, and these are just to name a few. Now, while ECS integrates natively with AWS services, it doesn't mean that the customers cannot use their favorite tools with ECS. So we have selective integration with the most popular tools and services in the market to reduce decision fatigue for our customers. And in order to achieve that, we partner very, very closely with companies. And the idea is to build kind of a streamlined experience. For example, we ensure that Terraform supports the latest feature that ECS launched. Now, let's double click on AWS Fargate, which is our serverless compute service for containers. ECS is optimized to work with AWS Fargate. What does that mean? AWS Fargate is a serverless compute engine for containers. It means that it makes it very easy for you to focus on building your container-based application. And Fargate takes away kind of all the burden of managing your own virtual compute infrastructure. There are no instance types to select or to monitor. There is no operating system to patch. What you choose is your CPU and your memory, and you only pay for your CPU and memory. Now, we talked about what are some of the reasons that customers are choosing ECS. Now, why does customers choose Fargate? Customer move to Fargate because it's easy to use through a managed host operating system. It also is secure and compliant, especially for running sensitive workloads. It also provides ephemeral storage for application, and there's no patching that is required. Now, we spent time talking about Orchestrator with ECS and EKS. We touched a little bit about AWS Fargate with our serverless offering. So I want to spend a little time talking about provisioning, and I'll focus on App Runner, especially for that is built for production for web application that are built at scale. And the idea is to make developers' life even easier. App Runner provides a highly abstracted and simplified experience for running web application and API servers. So with that in mind, why does customers choose AWS App Runner? First of all, App Runner is very much suited for web application and front-end or back-end API server, especially anything that has an HTTP request reply-based service. And customers are telling us that what they love about App Runner is the fact that it helps increase productivity because it focuses on application development and not on the network, servers, pipeline, orchestrator. It also have a very flexible deployment. So you can go really quickly. You can go directly from an existing container image or source code to running a production app in a matter of minutes. We also have automatic scaling, so you can scale up and down as needed, and that will ensure consistency and low latency for your application. Like any other AWS service, security by design. So this means that there is workload isolation on its own kind of dedicated runtime environment and so on. We talked about observability. So App Runner takes away even more of the management overhead, but customers still want to understand what's going on inside their environment. So App Runner is coming with out-of-the-box observability, and it has kind of an extensive suite of logging, monitoring tools, and so on. And one interesting data point is we offer granular pricing. So if you look into App Runner pricing, you pay per second with a very granular request-based pricing. Okay, so we covered cloud, we cover orchestrator, we cover provisioning with App Runner. Let's double click on hybrid environment. I think Gary mentioned a lot of that in his last slide when he was talking about what's the trends he sees in the market, and customer needs to continue living in these hybrid environments between kind of the cloud and on-prem. So let's talk about hybrid environment. Now, as part of the voice of the customer effort, we spoke to many of our customers and ISVs. And what we heard consistently is that they need to operate a separate local containers management software in a hybrid environment, and for very good reasons. Our customers have a very specific purpose to keep some of their workloads closer to them. And then if it's data management or things like security or simply investment that they've done in their local environment that they don't want to move to the cloud. And there are also very specific challenges for customers facing, especially around operating containers application in a hybrid environment. What we heard from our customers, they want something that is simple. They want consistent tool set across cloud and on-premise, and as well as kind of they want to figure out how to have their existing investment in infrastructure. If they need to retire it, what can they do? And also, there are some cases where they have to deal with kind of local compliance and regulation. So Maybe some interesting data points on what we see in terms of these hybrid environments. What does customers are looking for when they're talking about a hybrid environment? What are the customers we see? We see customer coming from factory floors, production lines. So if you think about IoT devices management, they have some of their workloads running in the cloud. Some of them needs to be running close to the device, close to the machine. We also see hospitals, laboratories where low latency is critical. Also, we want to see customer, or also the data needs to stay local. There needs to be a fast processing on-prem. We see customers from hotels, restaurants, supermarkets, convenience store, like local point of sale, where they need to be able to continue running their application, even sometimes in a disconnected mode, or they need to have low latency processing. Something happens, there is a power outage, they still need to be able to continue running their store. And then we see an interesting use case for things like cruise ships, and in the automotive industry, things like connected cars, mine, oil, gas, exploration sites, and rig, where you have something that is in the middle of the ocean. There's not necessarily a cloud, there's not necessarily connectivity, but you still need to be able to operate everything you have designed on a cloud, on a local device, and things need to keep on working, and you want consistency. And once you have connectivity, you want to be able to kind of connect these disconnected modes and kind of download the data or understand what happened and so on. And then one more interesting use case when we're talking about a hybrid environment is really around kind of TV, movie sets, I would even say gaming industry, where you're focusing on running kind of low latency. You need things that are very close to the gamer or the streaming, and you want to be able to provide kind of a seamless experience. So you're going to run some of your streaming mechanisms on a local device. And with that in mind, we listened to the feedback. And I think it was May last year when we launched ECS Anywhere. And the idea was to help our customers to standardize containers management across all their environment. And the idea is to enable the ability to have an on-premise environment with ECS and ECS Anywhere. Now, it simplifies and reduces the complexity for customers migrating containers workload to the cloud, because our customers no longer need to operate separate local containers management software such as Mesos or Kubernetes. And we roll up more features, including support for GPU instances or things where we see early success around the hybrid solution we launched. There are also kind of key use cases we hear from our customers. I mentioned several before, but let me give you two more specific examples. We talked to one of our ISVs, and they build image rendering technology. They're moving from EC2 to ECS, and the idea was to enable effectively compete kind of an on-prem business for an automotive company. Another example is gaming software company that had a mix of legacy applications that needs to stay and run on-prem, as well as their new application running on cloud, and they wanted to create this hybrid environment with some of their workloads running in the cloud and some are working on-prem. And then all these customers want to run containers data processing workloads on the edge as well as in the cloud. We also see things like factory floor, machine data aggregation, and they look on ECS Anywhere to solve the complexity of their hybrid environment. Now, finally, we have customers in industry vertical that are highly regulated, and those who want more control over their infrastructure that is managed. And it's a very integrated in a consistent tool set so they can use these applications. They also need solutions that do not need a lot of compute to run, and they want to support on bare metals and Windows and so on. We're looking to serve these needs of the customers, and we're working both with hardware and managed services provided partners. So here are some quotes from customer success stories that I want to share with you before we ramp up. I will not spend a lot of time on that, but you can see that Volkswagen is using AWS, and their focus is to migrate specific virtual reality rendering and 3D optimization workload to the cloud. They're using their own custom application, and they want to deploy a managed VR application using a lot of AWS services, including ECS. Research is a leading provider of software in advanced cancer treatment. Very important mission. And they work with different clinics around the world, and the clinics rely on their solution. So the company has an on-premise treatment planning solution to generate and evaluate radiation therapy treatment plans. Last use case, very interesting, recently came from 3DI, which is a cloud video surveillance provider. And they want to simplify the installation process for their customers by building kind of a scalable, flexible architecture in the cloud. And because many of its customers uses on-premise hardware equipment of their own, 3DI wanted to set a set of solutions that would support hybrid infrastructure and also handle vast amount of continuous streaming data from over 50,000 customers. So we talked a lot about the benefits of containers. We talked about infrastructure management, hybrid solution. But what I want to leave you with is scalability. So Amazon ECS is adopted an unprecedented scale. These are some of the older numbers, but I just want to leave you with that we have over a billion task launch every week. We also support tens of thousands of API requests per second. I think it's about 70,000, but likely more by now. And then some of the largest companies in the world innovate using ECS, including our own Amazon. Now it's more than that. We're available in 19 regions and 6 continents. We have local presence, and this means that there are more regions coming this year, and ECS will be available in even more regions in the near future. So with that in mind, you're probably asking me, okay, so what's next? What else are you guys going to continue innovating for us? And our biggest focus is on improving the customer experience and then making your life simpler. And I cannot give dates here, but I want to give you some preview of some of the few big releases that are coming. So we talked about the ECS scaling. We continue investing in scaling, even larger scaling coming this year. Granular deployment. Networking is something that makes me excited. I call it we are reinventing our networking, and the idea is to bring modern networking into ECS out of the box. So you can think about things like service mesh and service discovery being highly available within ECS. And then ECS Anywhere, we just talked about a variety of use cases and also some of the initial success stories we have. And the idea is that we're going to add Windows support as well as load balancing support. Fargate, our very unique serverless offering. We are also going to continue improving scaling. We're adding things like large task size support as well as GPU. So all the ML AI training models that requires heavy computation are going to be optimized even further with the work that Fargate is doing right now. We also talked about some of these experiences that are being built on top of ECS, and App Runner is a good example being built on top of ECS and Fargate. And we already released VPC connectivity. We already released X-ray support, and there are new languages and runtimes that are coming this year. And some new use case. And again, the idea is that we want to increase your productivity. We want to offer more features with kind of a hands-free experience when it comes to web development and backend application development. So those were a lot of words and a lot of data that both Gary and I shared with you today. So thank you so much for attending and for listening to this session. And we're very eager to talk to you about your container application, your journey, and as well as understand your needs. In the meanwhile, please go check out ecsworkshop.com and take a look on the demo and how we're making onboarding on containers easy with ECS. There's a lot of material, use cases, case studies that are available. I suggest that you check them out. And I'm looking forward to meeting you all with Gary in our Q&A session. Thank you so much.